So this is the second part of the introduction to solving absolute value inequalities. In the previous video, I gave you the basic rules on how to set up your two different inequalities to solve it. In this video, I'm going to give you a couple of different examples and the different types of scenarios that you'll see in the way your solution sets look. So remember that when you're solving these, you need to isolate the absolute value. So nothing on the left, nothing on the right. Once it's isolated, you can break it up into your two inequalities. Okay, you have your positive side, which you just copy down what you have. You have v over 7 is less than or equal to 2. And on the negative side, remember, two things happen. You have to change your sign. Okay, and that's talking about whether it's positive or negative. And the second thing that happens is you have to flip your inequality. If you're not sure why this happens, go watch the previous video. So you flip your inequality, super important, and change your sign of the value on the right. So we have b over 7 is now greater than or equal to negative 2. From here you can go ahead and solve. So we're dividing by 7, so our inverse operation is to multiply. The easiest way to get rid of a fraction, remember, is to multiply by the denominator. So this cancels on this side. We're left with v is less than or equal to positive 14, or the union. Same thing over here. We multiply by 7 on both sides. That cancels there. v is greater than or equal to negative 14. Okay, so we've solved these inequalities and we can go ahead and plot them on our number line. Negative 14 over here, positive 14 on the right. So v is greater than or equal to negative 14, close circle here. Greater than is to the right. And v is less than or equal to positive 14, close circle at 14, less than is to the left. So here we have our graphs that are pointing towards each other, and they're going to be bound by these endpoints over here. So your actual solutions that you're going to graph are closed circles at the negative 14 and 14, and they're actually going to be connected. Okay, they're bound by those closed circles on either end. Okay, so that's your solution. Remember, you can write your solution set like this. You can write it as an inequality where v is less than or equal to 14, but greater than and equal to negative 14. Okay. And you can also write it in interval notation with your brackets. So negative 14 on the left, positive 14 is your upper bound on the right, and there you go. Okay, all of these are the union of the two solutions. So let's do the one over here on the right. Okay, nothing on the left, nothing on the right. We go ahead and split up our two into our two inequalities. So negative 4m plus 3 is less than negative 5. And then on the right, remember, two things happen. You change your inequality sign and change the sign of the number on the right. So we have negative 4m plus 3 is now greater than positive 5. Okay, when we go about solving, okay, so minus 3 on each side. Okay, that is 0. Negative 4m is less than negative 8. Divide both sides by negative 4. Remember, we're dividing by a negative, which means our sign is going to change direction. We're left with m is greater than positive 2. Or the union of this right side over here. So when we moved that 3, they canceled. We're left with negative 4m is greater than positive 5. Divide that negative 4. M is greater than negative 5 over 4. Okay, So when you go to draw it on a number line, okay, negative 5 over 4, it's going to be 1 1/4. Okay, so it's going to be an open circle at 1 1/4. Greater than is to the right. And then we have m is greater than 2. Open circle over here to the right. Okay, because we're talking about the union, we are going to graph the one that covers the most space. So if you extend these two graphs out here, that one goes there, and this one's going to come over here. So you're going to pick the one that covers the most space, which is that m is greater than negative 5 over 4. So you're going to have an open circle here with an arrow pointing to the right. Okay. And for your solution, you could just say, m is greater than negative 5 over 4. Because if you say m is greater than negative 5 over 4, we also know that m will be greater than 2. Two more examples that I have for you here. In these examples, your absolute value is not isolated, so you need to make sure that you get it by itself. Over here we have that negative value in front of that absolute. So before we can split it into our two equations, we have to get rid of it by dividing by negative 1 on both sides. Red flag. As soon as you divide by negative 1, you know that you need to change that inequality sign. So now that we've gotten rid of the negative over here, we're left with the absolute value of k minus 8 is less than positive 4. From here, we can split it into our two inequalities, the positive side, which is just k minus 8 is less than 4, and the negative side, remember, two things happen. Your inequality changes and the sign on the right becomes negative. So we have k minus 8 is now greater than negative 4, which we can solve by adding 8 to both sides. Okay, that cancels here, so k is less than 12. And that cancels here on this side, so k is greater than positive 4. These are joined with a union. Okay, and you can graph them on the number line. Okay, we have 4 and 12. K is less than 12, open circle, less than to the left. K is greater than 4, open circle, greater than is to the right. Now in this case, we have both of our arrows pointing towards each other, so we're going to have a connected line here in between those 2 points. When you have this, you can write it as an inequality, where you have k in the middle, and you have k is greater than 4 and less than 12. Okay, you could also write it in interval notation, 4, 12, with your parentheses on either side because you have the open circle, so they're open brackets. To solve this one over here on the right, we have that denominator of 2. Remember, the easiest way to get rid of a fraction is to multiply by the denominator. So those cancel here and here. And we're left with the absolute value of n is greater than or equal to negative 4. We have no extraneous solutions here. Okay, this is going to be a positive, so it will be greater than that negative number. You split them into your two inequalities. Your positive side, n is greater than or equal to negative 4, and your negative side, where you flip the inequality and change the sign on the right. N is now less than negative 4. You have that double negative. It's going to become a positive. N is less than or equal to positive 4. Or the union. So when you plot your number line over here, you've got negative 4 on the left, positive 4 on the right. N is less than positive 4 or equal to, so close circle here, less than is to the left, and is greater than or equal to negative 4, close circle at negative 4, greater than is to the right. And this is another one where you have your connected points here. All right, if you want to write that as an inequality, your solutions as an inequality, you have n in the middle. N is less than or equal to 4, but greater than or equal to negative 4. Okay, or if you wanted to write it in interval notation, they are less than or equal to you, so you have your square brackets on either end, lower bound, upper bound. Okay, that's it for the examples here. If you have any questions, let me know in class. Feel free to send me a remind, shoot me an email. Otherwise, you should be able to get through most of the homework assignment for 2.3.